Hi, my name is Kiu Chang, and today I'd like to present my project on analyzing X-ray images with CNN. What is CNN? CNN stands for Convolutional Neural Network. Recently, it has become a very popular model for image and pattern recognition. A network of neurons that is composed of artificial neurons or nodes. It's highly interconnected network with billions of neurons and with trillions of interconnection between them. So connections of the neurons are modeled as weight. A positive weight reflects an excitatory connection, while a negative weight means inhibitory connections. CNN has three main advantages: reducing overfitting, reducing computational cost, extracting representative feature from inputs in tensor. So data set came from Kaggle. It has roughly 6,000 X-ray images of children between age of from 1 to 5. The data is subdivided in three different categories: the train, test, and validation. For the train data, there are 5,206 X-ray images with 3,875 are positive for pneumonia and 1,331 are normal. For test data sets, there are 624 with 390 with pneumonia and 234 are normal. Validation has 16 images, 8 pneumonia and 8 normal. As shown in the pictures on the right-hand side, the X-ray images are quite clear. You can see different organs, ribs, pretty clear images. And some of the images here show that, like with pneumonia, there should be a little bit of cloudiness shows, around here, and this area should be clear, but this should be like, if it shows cloudiness, meaning that it has pneumonia. And it's very difficult to look at the images and tell whether someone has this or not. And so hopefully with using X-ray with the CNN, we can actually analyze the data better. So what is convolutional neural network? It has multiple layers. First, the image, input image is feed and carried with the convolution layer, and then go to nexus to max pooling, and then finally fully connected layer. A model performed under particular kernels and weights is calculated with a loss function through forward propagation on training dataset. The learning parameters, the kernels and weights are updated according to the loss value through back propagation with the gradient descent optimization. In this case, it's Bailu linear ratified linear unit. Here, show here is a matrix. The column on the square on the right hand side is true negative, and this is to the bottom one is false negative. So left, so I'm sorry, so the right hand side, top right is false positive, and bottom right is true negative, true positive. And on this diagram here, this is the training and validation accuracy. So this is with the circle up here. This is the training accuracy, and the line here is a represent validation accuracy. The training has a very nice curve versus the validation has a little bit more noises. And here, this is the training and validation loss. So pretty much similar to the curve, to the graph up here, but it's opposite because hopefully by when training the model longer, we eliminate some of the loss. And represented at the bottom here is actually number of epochs, and shown here there are 1,000 of them. I'm sorry, 100 of them. So this is one the image of the first convolution layer. Some of them show up pretty nicely, and some of them are harder to see. And this is the fourth convolution layer. And comparing the fourth convolution layer with the first, the image is actually very, very different. This one is, the first one is more defined. You can see the outlier of the body, the organs. The empty space here represents the lungs. And this is the heart. And this is the diaphragm. And on this picture here, we can't really tell the different organs. There's some pigmentation picked up right here. This pigmentation might be represent some features that the model picked up. And we have like 7 layer total, and this is only the 4th. For future works, I would like to add more layers to see how the model performs, increase the number of iterations required, which require more computational power, which is not doable by a personal computer. Include more validation data. Since the validation data is quite small compared to the only 16 of them compared to almost 6,000 of the training images. Consults with X-ray radiologists to evaluate the model. And that's it. Thank you.